Finish off Unit 3 today with what would appear to be a little bit of a letdown from the challenging lessons that we've been doing recently with graphing and polynomials and all that. So we're going to be talking about variation today, and we've got two learning targets. Neither one of them off the charts difficult, no graphing. So learning target 12, write and then solve variation equations, so just kind of in a plain sense. And then basically do the same thing but with some applications. So you've got some real life stuff connected to it. All right, well, just a little bit of vocabulary here. So what are all of the different types of variations that you're going to have to work with today? Well, the first one is called direct variation. And direct variation is just simply an equation or a function that's in the form y equals k times x. Y equals something times x. And we call k a constant, the constant of variation. Every once in a while, you get something called, the square direct, or it varies directly with the square. In which case, you would get y equals k times x squared. So that's the square, the direct variation, but it works basically in the same way. We've got inverse variation, and so this is y equals k divided by x. And again, k is the constant of variation. And again, sometimes you'll wind up with the square of variation, so you'd have k over x squared. And then you've got joint variation or combined variation, which are kind of the same thing. Combined variation is when you just have two or more independent variables. But joint variation is specifically when you're multiplying with those multiple variables. And so it might be something like y equals k times x times z. So it's a lot like direct variation, except you just have multiple things and you're multiplying them. Again, you might wind up with some squares in there. So be prepared for something like k times x squared z squared. Okay. So what's going to happen is you're going to be given some information for your independent and dependent variables, the x and y, or the x, z, and y, and you're going to have to figure out what your constant is. Once you have that constant, you're going to go back and rewrite it with the constant, but then with the independent and dependent variables, and then you can use that to basically solve any equation. You'll have a number of examples that show you how to do that. So this one right here is learning target 12, just like the super simple one. You take a look at it and it says if y varies inversely. So there's my keyword. I know that it's going to be k divided by x. Okay, so I know that's the form of what we got going on. And then it says as inversely with x. And y equals 10. Okay, so now I'm just filling it in for my variables. Y equals 10, I don't know the constant yet, when x equals 3. So now I just very simply solve for k, multiply both sides by 3, and I wind up with k equals 30. I can now rewrite my inverse variation equation to be y equals 30 divided by x. And now I finish it off. It says find y when x equals 20. Well, that just means I'm going to say, all right, y equals 30 divided by 20. And so y equals 3 halves. Okay, so you got two parts to it. Write your inverse variation equation, and then go ahead and do that with an extra piece of information. All right, well, that's the simple version. I don't think you're going to have a whole lot of problems with that. The application questions work essentially in the same way. You're just going to have a little bit of context to it. So it says the area of a rectangle varies directly. So there we go. There's the keyword, varies directly as its length. And so I might even put different variables in here. Area is equal to k times the length. So instead of x and y, I've got length and area. And then it says if the area is 50 meters squared, when the length is 10, okay, so just stop here for a second. Let's write our directive variation equation. Solve for k, solve for my constant. I divide both sides by 10. I get my constant is equal to 5. And so that means my direct variation equation is area equals 5 times the length. Now I continue on. And it says find the area when the length is 25. Well, area equals 5 times 25. And that's going to give me 125 meters squared. So that's it. Let's do a couple other variations. Pun intended. In a certain manufacturing process, it says the cost of producing one item varies inversely. Okay, so there's my keyword. I know it's going to be k divided by something. As the square, okay, of the number of items produced. Okay, so let's see, the cost, we'll call that C, varies inversely, so k divided by, and then the square of the number of items produced. Well, I'm going to call items I, and then I'm going to square it. All right, well, let's move on. It says if 100 items are produced, so that's 100 items down here, and each costs $2. If this is the case, well, now I can go ahead and solve for k. Or sorry, it's not C, it's 2. Let's save that. All right. So let's solve for k now. So I get 2 equals k over 10,000. Multiply both sides by 10,000, and I get k equals 20,000. So my direct variation equation, the cost is equal to 20,000 divided by the number of items that I have squared. All right, so I've got my squared inverse variation equation. Now I go on and find the rest of it. It says find the cost per item, C, if 400 items are produced. So now I've got 20,000 divided by 400 squared. Don't forget that you're still squaring it. Well, 20,000 divided by 400 squared is going to be 0.125, which would be approximately, so the cost per item would be about 12.5 cents per item. All right. So there's another quick example. Let's do maybe one or two more here. It says the area of a triangle, so area equals, varies jointly. So remember, jointly is when we have multiple independent variables and we're multiplying them. So as the lengths of the base and the height. So you got your constant and then the base and then the height. Well, it says a triangle with a base 10 and a height of 4 has an area of 20. Okay, so let's go ahead and figure out what our constant of variation is, although I'm willing to bet that if you've passed elementary school math, you got a pretty good idea what it is anyway. So we wind up with 20 equals k times 40. Divide both sides by 40, and k equals, oh, shocker, 1/2. So it looks like we're saying that the area of a triangle is 1/2 times the base times the height. Oh, that's new information. All right, and now we just need to find the area of a triangle with base 3 feet. So 1/2 times 3 times 8, and 3 times 8 is 24. Half of 24 is 12. So there's kind of an interesting application there. I guess don't forget we've got feet squared. All right, let's go ahead and move on to the last one. I would guess that this one would be the most complex of the ones that we've done today. It says the number of vibrations per second, so in other words, the pitch, of a steel guitar string varies directly, okay, so there's my first keyword, I'm multiplying, as the square root, of the tension, and inversely as the length of the string. So we got a lot of information going on here. Varies directly as the square root, so varies directly means I got k, and then times the square root of the tension, so we'll call that t. But then inversely, so k divided by the length. Okay, so there's what we got. Here's the information. It says if the number of vibrations per second is 50, so I got 50 in for V, and then the tension is 225, so square root of 225. And the length is 0.6, so divide by 0.6, we can now go ahead and solve for K. All right, well, the square root of 225, that's going to be 15. So I got K times 15 divided by 0.6. I'm going to go ahead and multiply 50 times 0.6, and I get 30. So 30 equals 15 times K. Divide both sides by 15. You got K is equal to 2. So my constant of variation is 2. So I'll rewrite my function here. V equals 2 times the square root of the tension divided by the length of the string. All right. So to finish this off, okay, it says find the number of vibrations per second. So V equals, when the tension is 196, so 2 times the square root of 196, and then divide by 0.65. So square root of 196, I believe that's going to be 14. And so as I finish this up, 2 times 14 is 28. 28 divided by 0.65 is going to give us approximately 43. Okay, so the number of vibrations is equal to 43, or approximately 43. All right, well, that finishes off Unit 3, which finishes off semester